Hello, my dear friends. Welcome you all in this science class. I am Soham Jagat. In the last lecture, we have discussed about gravitation, introduction to gravitation, and about Newton's conclusion and moon moves around Earth and what is the reason behind that, and also discussed that there is a force acting between any two bodies in this universe. So we call this force as gravitational force. In this class, we will continue in our chapter number 10, that is gravitation. Let's see point number 10.1.1. I hope you are sitting with your textbook and also with different color of pen to mark important points and questions. So let's begin this session. 10.1.1 Universal Law of Gravitation. Universal law. By word universal, which means this law can be applied to anything, anything in this world. So this law is called universal law because it is applicable to whole universe, whether it will be or it is terrestrial body or celestial body. It can apply to any body on universe. So this is called as a universal law of gravitation. Important point, first sentence. Every object in the universe attracts every other object with force which is proportional to product of their masses and inversely proportional to square of distance between them. Now we know about there is some force which acts on every body on this universe. Now we want to find the magnitude of this force. Now we want to find magnitude of this force. Now to calculate this force, we need some formula. We need some law. So for deriving this formula, Newton observed some and phenomena and behavior of object, and from that behavior it arrived properties by which it exert force on one and another. So we have universal law of gravitation as a sentence. We have to remember this sentence. Mark it. Every object in universe attracts every other object with force that is proportional to product of its masses. Proportional to product of its masses and inversely proportional to square of distance between that two object. For example, here we have two object, let's say object 1 that is A and second object is object B. We have two object. Mass of object A is capital M and mass of object B is small m. And we have distance between these two objects as d, as we can see here. You can remember this figure, and whenever this question asked in our examination, we have to draw this basic figure which denotes one object A, another object B, object A with mass capital M, object B with mass small m, and distance between these two objects as d, as we can see here. So this is basic figure. Let's derive formulation and formula of this gravitational law. We have two objects A and B of masses capital M and small m lies at the distance of d from each other, as we can see in figure. let the force of attraction between two objects is capital F. We assume that there is a force between these two objects, that is capital F. So according to the universal law of gravitation, this force is proportional to multiply or say product of their masses. Product means multiplication. So here we write F is directly proportional to capital M into small m. What is capital M and small m? That is nothing but product of or say multiplication of masses of this object. We have object A and B. Its mass are capital M and small m. So this force that is acting on this two object F is proportional to M multiply M. So we gave it equation number 1. And the force between object is inversely proportional to square of distance between them. Now we know we have distance between these two objects as small d. So we write F is directly proportional to 1 upon d square, or we can say that F is inversely proportional to d square, as we can see here. What I said, F is directly proportional to 1 upon d square, and we can say F is inversely proportional to d square, that is same. Okay, so we have equation number 2 here. Let's combine these two equations. We have F is directly proportional to M multiply M divide d square. What we do here? We combine these two equations. That is equation number 1 and equation number 2. F is directly proportional to now product of masses. Product is multiplication of masses of both objects. So capital M into small m, and inversely proportional to square of distance of these two objects. Distance between these two objects. So we have F proportional to capital M multiply small m divide d square. Now we know from chapter number 8 and 9, proportionality sign. If we want to remove this proportional sign, so we have to input or insert proportionality constant here. So we remove proportionality sign here. So we have F is equal to M into M divide D square multiply G. Here this G is proportionality constant. G is proportionality constant. This G is universal gravitation constant. So we have this proportionality constant G here, which we denote by capital G, and it is known as universal gravitation constant. Now, if we want to find SI unit of this G, what we have to do? We have to make subject of this G. We have to make as a subject. So we can do here this D square. This D square will be multiplied with F. So here we have F into D square is equal to G capital M into small m. Here equation. We have here equation F D square is equal to M into M into G. Now here we have small m and capital M. Put this small m and capital M in denominator of FD square. So now we have this equation 10.5, that is G is equal to F D square divide M into M. Capital M multiply small m. What is G? that is universal gravitation constant. F is force between these two objects, particularly gravitational force between these two objects. D is distance between these two objects. Capital M is mass of object A and small m is mass of object B. Now, if we want to derive SI unit of this G, we have to find SI unit of all this quantity. Here you can see F, D square, M and M. Now we know that SI unit of force, that is Newton. So here we have Newton. D, D is distance and SI unit of distance is nothing but meter. Here we have D square. So we have a meter square. So you can imagine in numerator Newton meter square. In numerator Newton meter square. In denominator we have two masses. We have two masses and SI unit of mass is kg. So in denominator we have kg multiply kg. So kg multiply kg, that is kg square. So we have Newton meter square divide kg square. You can say this Newton meter square divide kg square. So here we have equation of G, that is 10.5, and SI unit of G, that is Newton meter square kg raised to minus 2, or we can write it as Newton meter square per kg square. Both are same only. So here we mark this SI unit of G, and important point, the value of G was found by Henry Cavendish. Value of G found out by Henry Cavendish by using sensitive balance. By using sensitive balance. The accepted value of G, mark this, name of Henry Cavendish, and also accepted value of G, that is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Who found the value of G? Henry Cavendish found value of G, and accepted value of G is 6.673 multiply 10 raised to minus 11, and don't forget to write SI unit of G, that is Newton meter square per kg square. So mark this both point, SI unit and accepted value of G. We know that there exists a force of attraction between any two objects. Any two object means any two object in this world. Me and this table, me and this laptop, and any two object between two planets, between any two body, there is force existed between two object. Compute the value of this force between you and your friend sitting close by. Now what we have to do? We have to put value. We have to put value in this equation. Which equation? This equation number 10.4. If we put value of me and my friend, or say you and your friend, F, that is force, gravitational force between me and my friend, gravitational force between you and your friend. What we have to do? We have to put value of G here. We have now standard value of G with us. Mass of your mass and your friend's mass and distance between you and your friend. Mass we put in kilogram and this distance we put in which unit? Meter. We put distance in meter, not in centimeter or in kilometer or decimeter. We have to put value in meter. If we find this value, you will find out that this value is very small. This value, that is gravitational force between you and your friend or you and other object, that is very small. Why that is very small? See here, you can observe this value of G, that is 6.673 into 10 raised to minus 11. 10 raised to minus 11, that is very small value. So we have this force is not much prevalent. So we can not feel it with higher magnitude. This is very small force. That's why we are not attracting toward each other, because this force is very, very, very low. Here we have information. The law is a universal in the sense that it is applicable to all bodies. As we discussed in starting of this lecture, universal means it is applicable to all bodies, whether the body are big or small, or body is celestial or body is terrestrial. It is applicable to all body, big and small, celestial and terrestrial. That's why we called this law as a universal law. Inverse square. Now we have to understand what is inverse square. In the formula of F, we seen that F, that is gravitational force between two objects. We seen that F is equal to G m into m divide d square. This d square is square of distance between two objects, which means now you can understood by discussion of our past lecture, that is inverse proportion means if one quantity decreases, one will increase. If one increases, other will decrease. That we called as inverse proportion. So here gravitational force is inverse proportion with square of distance between these two objects. So what is the meaning? Let's see. Saying that F is inversely proportional to square of D. For example, D gets bigger by factor 6, which means if at this time you and your friend is 1 meter from each other, so there is certain value of gravitational force between you and your friend. Now you are 6 meter away from each other. Getting the point? You are from 1 meter, 6 meter far from each other. So that means D gets bigger by factor 6. It means force will be 1 by 36 times smaller. Force becomes 1 by 36 times smaller. Why? Because in first situation where you and your friend is at 1 meter distance, at that time value of D is 1. So square of 1 is 1. Now we have value of D is 6. So square of D, that is 6, is 36. So the value of F will be decreased by 36 times. So it means that F becomes 1 by 36 times smaller. So we have now our topic 10.1.2, that is importance of universal law of gravitation. Let's see what is importance of universal law of gravitation? This is our short answer type question. This is our short answer type question which can be asked in 2 marks. That is, what is important of universal law of gravitation? Then we have to write these 4 points written here. We have first point, the force that binds us to earth. We have question before that why we are standing on this earth, why everything on this earth is attached to earth's surface. There is some force that binds us to earth, but before discovery of this gravitational force, we don't have answer to this question why we are on earth and why we don't and why we are attached to earth's surface. So here the first point, the force that binds us to the earth is gravitational force. The motion of the moon around earth. We know that moon goes around earth. So here is the answer why moon goes around the earth. Another same question, the motion of planets around the sun. As there is a motion of moon around earth, we have motion of other planets around sun. So it also gives answer for that question. The tides due to moon and sun. We we know that in ocean or say sea, we have high tides and low tides. This tides is due to gravitational force of moon and sun. Sun is comparatively lower or say less responsible for high tide and low tide. The main reason for this high tide and low tide is gravitational force of moon. Let's try to understand this by figure. Here we have earth and here we have moon. Earth is rotating on its axis and same way moon is also rotating and rotates on its orbit, that is in this way. Moon is rotate in this way. Moon has some mass, that is mass is comparatively greater, larger, so it has some gravitational force between earth and moon. That means earth try to pull earth try to pull moon and moon tries to pull earth, but we know that this force is not sufficient and the motion of earth and moon is in such a way that it cannot move towards each other like this. So it has its fixed velocity and position. Now what happened? Let's say this blue surface, this blue surface is water on earth. This blue surface is water on earth. Here we have moon. So there is a gravitational force of moon on this earth's water. So what happened? This water is attracted toward moon. So here we have this bulge of water at this side. Here this water tries to move towards moon. So we have this bulge here. at same time. So now you can see here we have high tide. Here we have high tide. At same time, this earth also tries to move towards in some distance. So there is also create bulge at this point. There is also create bulge at this point. So here also we have high tide, but the bulge at this side is comparatively lower, and the bulge at this side is comparatively higher, because at this side, which is in opposite, exactly opposite to moon, that exert more force, that is experienced more force compared to this side. So it has higher bulge, it has lower bulge or comparatively less bulge. At this time, this surfaces, this two surface has low tide, and this two surface has high tide. So we have generally two high tides and two low tides in 24 hours. And similarly, moon travels on its orbit like this. So this bulge also travel with moon like this. If moon goes here, this bulge will be create here. This bulge will be create here. If moon goes here, this bulge will be create here. So now from this figure, you can understand that at this place, not every day high tide and low tide came on same time. There is a difference in time of high tide and low tide. Why? Because moon is changing its position by time. So we have different time of high tide and low tide. Now as we seen that effect of gravitational force of moon, that is more compared to sun. So what sun do? Sun, let's say here we have sun. Here we have sun. Here we have sun. It is comparatively larger and it is far from moon. But we have drawn here. This sun is try to diminish or enlarge the effect of moon's gravitational force. Now at this situation, it tries to oppose or lower the effect of gravitational force of moon, because this sun tries to pull this water towards it and moon tries to pull this towards it, so that this is opposite force and it will create diminishing effect. So effect of pulling of moon will be diminished by sun. And when and when this sun, moon and earth are in same line, then when this earth, moon and sun are in same line, on that day day this bulge will be largest. This bulge will be largest like this. On that day, this bulge will be largest, and we have highest high tide and opposite side as highest low tide. Why? Because here the moon also tries to pull this water in this way, and sun also tries to this water in this way, which means there is addition in force of gravity. So this both force act in same direction. So there is high tide is comparatively higher and low tide is also comparatively higher on other side. So now I hope you understood why high tide and low tide occur on earth due to gravitational force of moon and sun. So in this session we discussed derivation of gravitational force, formula for gravitational force. It is dependent on mass of both object and distance between object, and also discussed one small question, that is importance of universal law of gravitation.